Hello guys, today we're going to have a look at the Britain's NC Slurry tanker again, and we're going to try out a YouTube subscriber's suggestion of using an electronic speed controller from an RC car to drive our pump for our slurry tank. Well, the first thing I better explain is why this motor driver didn't work. This is the TB6612 motor driver that I'm using in the different tractors now. And I said in the last video that it could supply 3 amps current, but I was wrong there. It can supply 1 amp continuous current, 3 amps peak. So what that means is it can supply 3 amps in a short burst to get the motor spinning, but the motor then would have to be running at under 1 amp, whereas from our measurements we were taking 3 amps to drive our pump here. So that's why this motor driver chip didn't work for that. So Jens there had the good suggestion to try an RC car electronic speed controller. This is cheap because it uses old technology. On this side we have a H bridge made out of 4 dual channel MOSFETs. This has 2 H bridges built into it. There's basically 2 of these boards inside this chip. However, the FETs that are used on this board can carry a much higher current than the FETs inside this chip. So that's why this is a better choice for this application. Each channel of each of these MOSFETs can carry 6.5 amps. This is rated for 10 amps. So what they've done here is they've used the 2 channels of each MOSFET in parallel to give them a total capability of 13 amps, and they've rated it at 10 amps. The other circuitry on here is obviously just a little microcontroller. It will be this, a little microcontroller to take your servo signal and produce the pulse width modulation that controls the MOSFETs. And there's MOSFETs here which I would assume are used to drive the MOSFETs that are carrying the power for the motor. And you've little LEDs and capacitors here. That'll be a smoothing capacitor, voltage regulator, stuff like that. So it's all very simple, very basic. This is going to suit us perfectly because we can place it in here just up the front of the trailer. We can put our Arduino behind it, wire the servo connections nice and short so we shouldn't get too much noise on it, and add our battery in behind it. The battery that I'm going to use is going to be 2 of these 240, actually I think I've ordered 300 milliamp hour batteries, so there's going to be 2 of them in the back here to give us 7.4 volts, and then we'll have our pump and a little water tank, and hopefully that will give us enough power to spray some water for a minute or two, because the tank is going to be so small that this pump would empty the whole of this tank in like a second if it was well, not a second, in half a minute or something if it was full belt. Some of the features of the industrial motor drivers that you need for an industrial application is this can take a pulse width modulation at 100 kilohertz. This is only 2 kilohertz, so you're going to get a bit of whine and stuff like that. But if you were making a proper product, you don't want your user have to hear the motor whining every time it gets up to speed. I don't think we can get our Arduino up to 100 kilohertz, so this is a little bit overkill for our problem. But we should be able to get a high enough frequency, maybe to get rid of the whine from the motor. These type of chips will be a little bit more advanced if things like thermal shutdown and low voltage detect, all that sort of stuff that you need in a proper industrial application. But you don't need that in an RC car. Like, if the voltage drops, the car slows down, the battery's flat anyway. Or you can just measure the voltage with your Arduino and have it shut down at a certain time anyway. So you don't need those things with an RC car. So like Jens R has said, this is a lot less overkill and it makes more sense when we're trying to drive these high power motors. For the tractors though, I'd stick with these proper motor drivers instead of trying to add more complicated. I mean, why bother generating a servo signal to drive one of these things and have all these extra wires when you can just control a motor driver directly from the Arduino. Doesn't make sense, but in this application it makes perfect sense. Okay, well, I think I've droned on about the electronics for long enough, so I have a receiver here, a standard RC receiver and a standard RC controller, a 7.4 volt battery, and we'll just hook up our electronic speed controller to our pump here, and we'll see how good our control is, and see if we can figure out what kind of nozzle we're going to need to add to make this this pump spray a reasonable looking jet from the back of the trailer here without emptying the tank in a couple of seconds, because at full power this pump has quite a powerful jet, which would be great if we were trying to build a fire truck, but not for this. We want a kind of a, I don't know what you call it, a conical spray, I guess, but we'll take it outside and see what it's like. Okay, so here we are set up. We have our battery. I'm just using this bit of breadboard as a kind of terminal block. Our motor driver and our receiver. And our motor's over there. We have a bucket of water, and our output is here. So I have the controller here, so I can speed up the motor. That's full power. And we can restrict the flow quite a bit. So clearly with our electronic speed controller we're getting a great range of speeds, and when we hook it up to the Arduino hopefully we'll get similar enough. I don't think I'll have time to test that today, but I'll build up that circuit and it should be just a simple servo testing circuit. We should be able to get the same performance with the Arduino that we're getting with the receiver. We're only supplying the signal. It's not like we're supplying different voltage or anything. We're still going to be supplying from the battery, so that should be pretty much the same. So let's just have a little look at how we're going to get the spray from the output nozzle. Okay, I've added a little nozzle here to restrict the flow of water a little bit, which gives us more of a jet now. So we've a bit higher pressure. Then the next thing, I've just bent a little bit of copper with a little bit of a curve on it, and if we get the position right and the pressure right, we get a bit of a bit more of a spray of water, which is what I want from my slurry tank. I want it to spray the water around about the width of the trailer, maybe a little bit more, and I think that's the way to do it. So I'm going to make a nozzle in copper that will come out through the back of the trailer, and I'll make an attachment like this, and maybe perfect it a little bit so that it'll spray in that kind of configuration consistently. That's the plan as we go forward anyway. Well, that's all I have time for this week. In the next video I'm going to try and do the coupling for the back here. My plan is to make a fixed coupling up to about here, and then have either a jet nozzle like this or a kind of a long bar that will spread the water out wide, that will kind of screw onto the end here. That's the plan. I'm not sure if that's going to work, but I'll try and work it like that. So that's what I'm going to work on in the next video, because clearly the RC electronic speed controller is going to work to drive the motor. Thanks Jens R for that suggestion. If anyone else has any suggestions or any questions, post them below or in the forum, and I'll try and answer them if I can. And if you like the video, make sure and hit the like button, and don't forget to subscribe so you don't miss out on the next video in this series where I do the coupling. And that's everything, so thanks very much for watching.